Begin recording. Everybody, hopefully you've enjoyed a good weekend. Welcome to Histology Lecture. We'll start. I think we have, 14 participants. Great that everybody's here. Just want to give an overview of what we'll be doing. I've been thinking about it, and you're welcome to join in and chat about this. I'll put on the chat room as well. I'm planning on doing today Histology Lecture. We'll start with page 395. We will tomorrow do the introduction to the immune system, and then the following day, that is on Thursday, we'll wrap it up, actually, this exam 2 unit, with the material on the skin, an overview of the skin. And if you follow along with the syllabus, you can do the readings in advance. We can talk about it right after we're done with the lecture, what readings you should be doing tomorrow and the next day. And then on next Tuesday, a week from today, I thought we'd do exam 2. And I thought we would also do the practical the following day, get all of our tests out of the way on Tuesday and Wednesday at 9 o'clock. And then Thursday, we'll continue on with the bones. And we have our last test. I'll do that the last day of class. Now, if you notice, I'm outside. I've decided to change our scenery a little bit. And maybe you want to sit outside too. I don't know. Anywho, if you'll turn to page 395, we'll start Histology Lecture. I got a question about how many questions on exam 2. We will have 25 questions on exam 2 and 25 questions on the lab practical. I have to email you the practical after the lecture. I don't want to forget. And did I say practical? I have to email you the lab right after lecture, and that will be lab number 4, histology. There'll be some images, and we can talk a little bit about that right now. The practical will be given next Wednesday at 9 a.m., and it'll include your first four labs. The histo lab that I'm going to email you really draws mainly, and I made the practical up, it draws mainly from the histology atlas in your lab manual. So be sure to know the pictures, their names and locations of all the pictures in the lab atlas. That's what we do with the manual. That's what we do during the year anyway. So you're not really missing it. You're not at all missing material that you would usually cover during the lecture or lab during the year. Okay, 20 on the exam. No, 25 questions on the test. And I believe I had a request to have a little bit more time, and I kind of like that. So instead of questions plus 10 minutes, we'll do questions plus 15 minutes. So if you have 25 questions, I'll give you 40 minutes. If you have 40 questions, I will give you 55 minutes. Some people were a little strained for time. I'm not here to strain you for time. I'm here that, you learn the material and you are in a relaxed manner can do the test. However, if I give too much time, everyone, there's cheating. You know that. And so your professor here has to temper it between, the time between given too much time and then there's cheating, and not enough time and you're stressed out. So I think time plus 15 minutes is how we're going to operate. So you got 25 questions, you'll get 40 minutes. A minute a question, 25 questions, and then 15 minutes extra. And I think that's fair. Okay. I'm going to mute everyone and march on. Then we have plenty of time for questions afterwards. Let's start with just getting you guys. I'm going to mute you. I'll leave the chat room open so I can see it kind of on the side now and then. And then we will begin histology. All right. Okay. Let's do histo. If we take a look, and I'm going to get rid of myself too. I don't like looking at myself while I'm lecturing. No good, a little bit. But just so I can be dramatic. Anyway, everyone, the study of tissues is known as histology. Groups of cells performing a common function, having a common structure, are known as tissues. And we have 4 types of tissues. I always remember it as MEN and C. I'll highlight it. Men with a C. Muscle, epithelial, nervous, MEN, right? The first letter of each word. And then C is connective. Let's do an example. You know, go like this with your heart. That's heart tissue, known as, well, what is it known as? Muscle, right? A certain type of muscle known as cardiac. We're going to go over the specific characteristics of heart tissue today. Feel your skin. That exterior tissue is known as epithelial tissue. That's the E in the MENC. Epithelial tissue is covering tissue and sometimes glandular tissue, and it has certain characteristics. All the cells look a certain way. With cardiac tissue, all the cells look a certain way. They have to look different, right? Complementarity to perform different functions. So we're going to do an overview today of all the tissues. I think the most boring thing to do with histology is to do an overview of tissues and just go step by step and make it a matching column. I want you to see the complementarity between the structure that we look at and the functionality. So a cardiac cell is branched like this, for example. It makes it strong. It holds it together well. They have intercalated discs, we call it, little special desmosomes. Cardiac or heart tissue has to be stronger than your average fat cell, right? The fat cell has big blobs of vacuoles holding fat. Makes sense because that's how it's structured in order to perform its function. So the structure and function go hand in hand. One of the best classes I ever took in grad school was biological materials. It showed that certain materials are made in such a way in order to resist different pressures on them. And I'm going to walk you through why the tissues are structured the way they are. So it's not just going to be an overview of histology, but it is also going to be a reasoning of why the tissues are the way they are. Let's start with just the idea that all of these tissues are held together by something called extracellular fibers. There's 3 types of fibers: collagen, elastin, and reticular fibers. We'll talk about that at a later point. But these are strings that kind of hold your cells together. And also, this is a very complex word, sticky stuff. Sticky substances on cell coats. That really, it's a glue. We have various different types of glues that adhere or hold the cells together of a certain type of tissue. Now, let's begin with the E in the MENC. Let's begin with the epithelial tissue. Epithelial, as I said a moment ago, is covering and lining tissue. Feel your skin, that's epithelial tissue around your body. When we think of covering and lining tissue, we right away think of the skin because that covers most of us. But there's also linings all over us. There's a lining in the heart and around the heart to help the blood to flow smoothly. There is a lining of your digestive tract to help you digest food, you know, absorb food in and give enzymes out. There is a lining of the urinary and reproductive tract to allow things to flow smoothly. So there's lining within your body and on outside of your body. And the other type of epithelial tissue is known as the glandular tissue. Glandular tissue are exactly that. These are specialized groups of cells of epithelial that make hormones or enzymes. We know that an enzyme ends in ASE and breaks stuff down or builds things up. We know that a hormone is an internal chemical messenger. I just want to remind you of what these words are. Something's got to make them, and that's a gland. Glands are made of epithelial tissue, just so you know. Salivary gland. Anyway, as an example. Okay, let's talk about the functions of epithelial. Most of us think of the word protection when we think of epithelial and the skin. Covers, protect what's underneath. Epithelial tissue is covering tissue, and that protects what's underneath, right? Protects from dehydration. You don't dehydrate out. All your skin is kind of impermeable to water, prevents you from just losing water like a plant, and protects you from abrasion. But then there's absorption, secretion, and filtration. Each of these functions is particular to a specific type of epithelial tissue. And Let's take absorption. I just mentioned intestinal cells. The digestive tract is lined by intestinal cells that are, I will show you, uniquely structured to both produce things and absorb things. Secretion is the production of something. Kidney tubules are examples of types of cells that produce, be it different chemicals or hormones from the kidney. Filtration. These are types of, filtration means separation based on pressure, right? And these types of tissues often are very thin because like a coffee filter or any type of filter is often very thin with holes in it. Similar, we say that the glomerulus of the kidney, as are an example, the glomerulus or ball of capillaries of the kidney has single cell layers thick that filter out. And obviously the main point of the kidney is to filter. So let's talk, those are the two general categories and the four general functions of the epithelial tissue. We say that epithelial tissue are very tightly packed sheets of cells. They have tight junctions adhering the cell membranes together, and desmosomes, as you know, the desmosomes lock as spot welds the cell together. This picture of your epithelial tissue may be on the exam, and you should know all epithelial have this general structure that you see before you. Always, always, always there's a free surface of the epithelial tissue, okay? What does the free surface mean? The free surface means it is open to the lumen of the body. Lumen means open area, or open to the outside world. The apical surface is the free surface that does not attach to any other cell or any other tissue. The type of tissue comes next, and then underneath the tissue is what we call the basement membrane. The basement membrane, much like a basement in a house, sits on the bottom, you know, kind of is the foundation for the epithelial tissue above. And there's two parts of this foundation or basement membrane. One is known as the basal lamina, and notice I put little dots there. The dots remind us that it's a gluey type structure. It's gluey because it is adhering or attaching the epithelial to the connective tissue underneath. On the other hand, we've got the reticular lamina underneath the basal lamina. And look, I put lines. Everyone look here, I put lines. The lines are really fibers, mostly reticular fibers, maybe some collagen. You don't know what those mean yet, but they're like ropes that hold the epithelial foundation, you know, the basement membrane, to the connective tissue underneath. And so it's all roped together. That's the general structure of how epithelial tissue sits within the body. Now, there's three types of cells for epithelial cells based on the shape. One is squamous. I squash your head. Look, squamous. You see the squamous one? It's squashed. The word squamous sounds like squashed. Those are cheap-looking cells, right? There's not much to them. They're just like little pizza pies. Cuboidal looks like a cube. That has a little meat to it, but not that much. It's like a square. Then you have columnar. It's got a lot of meat to it. Looks like a brick. These are usually your functional cells. They do stuff, like in the intestines. They make enzymes. Squamous usually doesn't do much. They flake off. Here, go like this to your face. Flake it off. Did you know that more than 50% of the dust in your house is your own disgusting squamous epithelial flaking off of your skin? And the other 50% is the insects. So dust is kind of gross. But we'll talk about that when we do the skin. So we classify epithelia based on the shape of the cells. We also classify epithelial based on the number of cell layers that it has. If it has a single layer, we say it's simple. Simple epithelial. If it has a stratified layer, if it's called stratified, then that means it's two or more layers. So stratified cuboidal epithelial tissue tells you right away that there's two or more layers of cube-like cells. Simple columnar epithelial tissue means that there's a single layer of columns, right? Can you tell me what stratified squamous epithelial looks like? Absolutely. Stratified means it must have 2 or more layers. Squamous must mean they're squashed cells. That would be like the skin, bunch of squashed cells in layers. And now you can write on your resume, histological classification. That's one of your talents. I mean, because now you know how to classify epithelial, all right? You can write this lecture on your resume when you're done. That sounds good, right? Everyone likes that. Okay, why don't we start with the simple epithelial? The simple epithelial include, obviously, simple squamous, simple cuboidal, simple columnar, right? And there's one more I'm going to leave for the end in a moment. But let's start with simple squamous. Now, I want you to think about a single layer of squashed cells. What is that going to do? It's going to filter. That's what we started with. Because it's thin, right? A single layer of cells is thin, and therefore materials can get exchanged as you move through a thin layer. This is what all of our capillaries are made of. Simple squamous epithelial tissue. We have a single layer of cells in what we call the endothelium. Put a star next to the endothelium, this word, because that's a word you should know. Endothelium means the lining of blood vessels and lymph vessels, and it prevents there from being a lot of friction. So if you think about your arteries in your heart, you don't want there to be a lot of friction and turbulence, give you a heart attack. So you've got a lot of single, simple layers of cells that allow smooth flow of blood through. That's a low friction lining of the blood vessels. Mesothelium, on the other hand, is a membrane lining of the ventral body cavity, and it covers the organs. That's another type of lining in the body that looks like saran wrap that holds the organs together. So again, the anatomy fits the physiology. It's a lining, and it allows for not just exchange of material, but a filtering of the material. That's simple squamous. Simple cuboidal, on the other hand, now a cube's got a little meat and potatoes to it, right? There's a little meat or cytoplasm to it. So it's going to secrete or absorb. It's going to do both. Secretion, move a few materials out. Absorb, bring a few materials in. Kidney tubules are known for having simple cuboidal epithelial tissue because you've got to excrete, or let's just say secrete, and send out and absorb ions to keep your ion balance normal in your blood, okay? Your water balance to be kept normal by your kidneys requires the simple cuboidal epithelial tissue to give off some ions and water and take in some ions and water as needed. So simple cuboidal allows the kidney to do that, all right? When you go on and take higher level pathophysiology, you'll talk about all the diseases associated with it. Now, simple columnar, a column has a lot of meat and potatoes to it, a lot of cytoplasm, so it secretes and absorbs even more. And all of your lining from stomach to rectum of your body is made of simple columnar, all right? There are a lot of what we call microvilli, which are little hills. Microvilli are little hills on the surface, the apical surface of simple columnar epithelial. And what does a hill do? If you just have a flat surface, you're not going to absorb much. If you have a hill going up, that gives a lot of surface area on which to absorb and send out enzymes. So the microvilli allow your digestive tract to do a great amount of absorption and secretion, okay? A goblet cell is an example of a simple columnar cell that gives you your mucus. I'm trying to be a little silly here. Sends out some mucus. That's your mucus cell. So next time you cough and have mucus come out, just say, "Oh, it's my goblet cell." It's gonna make you a lot of friends. Knowing words like that, Very, very. This is a very cool class. You make a lot of friends with the words here. I'm being sarcastic, right? It's terrible. Okay. The last one, I told you that there's 4 types of simple epithelial. The last one is pseudostratified columnar epithelial tissue. It's a long word. I didn't want to tell you right away. Pseudo means fake, right? Like fake news, pseudo news. Pseudostratified columnar epithelial tissue means that it looks like it's columnar and it's stratified, but it's not. And in fact, if you take a look at the picture here, here's a picture of pseudostratified. The nuclei are uneven, making it appear that these types of cells are stratified, but they're not. It's really a simple columnar that's weird looking, okay? They secrete and absorb. They happen to be in your respiratory tract. So if you remember anything about it, remember that these are what line your respiratory tract, and they happen to have a lot of cilia and goblet cells. The cilia are little hairs. Cilia is a hair, and we talked about that in the last class. Cilia are hair that absorb, that kind of hairs trap materials in them. If you take a look on figure 11.1, all right, we are going through page 395 to 400 and whatever, 10 right now. If you look at figure 11.11, it gives you a little overview of the different types of tissues, and then 11.12 gives you the general structure of epithelia, and figure 11.13 shows some examples, okay? And the air sac of a lung in figure 11.13a is an example of a simple squamous epithelial, okay? I just wanted you to see these, an example of a simple squamous. Your lab manual is far better than the textbook because it gives you a whole lab atlas, okay? And again, I'm going to email you the lab right after we're done with this lecture, so you can start on that, and that's your last lab before the practical. Make sure you know all of the pictures and their names of these types of tissues. And figure 11.13a, right on page 398, has a picture of simple squamous epithelial. B is simple columnar, a kidney tubule. And looking at the digestive tract, figure 11.13C, C is simple columnar. So I just want you to see the pictures. They're better. And this is our pseudo-stratified picture. Now, why don't we move on to our stratified epithelia? Stratified are very different in their approach because the stratified have many layers, and many layers mean one thing. It means that they must be protective in some level, or they must have a ton in order to be very productive. So why don't we look? We say that all stratified epithelial tissue emerge from their basal areas. That means the bottom layer of the cells. And they grow out. So feel your skin. What you feel is dead. The very bottom layer is the only one that's alive, and that's what produces all the rest. And therefore, the major role of stratified is protection because you have a lot of layers. So we protect our tissue. And, it doesn't hurt, I suppose, to open up your lab manual to lab exercise number 4 and just look along. You don't have to. I mean, if I were a student, I probably wouldn't do it. Just take my word for it. You can, if you want, though, open up lab 4, and there's your whole atlas for all the tissues. And it gives you this overview, and you can kind of look along and look at all the stratified. The picture of the stratified squamous epithelial shows many layers, okay? Many layers in order to protect. And protect from what? Wear and tear. The keratinized layers on the skin, what do I mean by keratinized? Keratin is a protein. Remember that word, keratin. Feel your hair. Feel your skin. Feel your fingernails. All pure keratin. Your skin is impregnated with keratin. And keratin is a protein to protect. That's really its function in the body. So we say that the skin is keratinized, or that it is filled with protein. And we say that the basal layers look, this is not too important, cuboidal or columnar, but the apical layer is squamous. So when you classify tissue, always look at the apical layer, and that's what stratified tissue is called. Because sometimes it looks a little different. I'm not trying to make everyone into a histologist, but I'm giving you the key points on how to identify tissue. And if you look at the apical or free surface layer, that better helps identify the tissue than the basal layer. That's further down, okay? Okay, Stratified cuboidal and stratified columnar are both rare. I don't want to spend a ton of time on them. You know, mammary and sweat gland ducts have stratified cuboidal, okay? It means 2 layers of cuboidal tissue. They are not, you know, they're not very common. Stratified columnar is in the male urethra and the pharynx. The pharynx is the back of the throat. They usually form junctions between one cell type tissue and another. But they do exist. I have to mention them. My favorite of all is transitional epithelial. I'd remember that. What the heck? And it's in your manual and in the atlas. It is what is found in your urinary bladder. It helps you to prevent your bladder from exploding. Let me tell you how. I was like this when I learned this in physiology. Basically, the apical cells are bulbous and they respond to pressure. As pressure builds on transitional tissue, the transitional tissue changes shape from a cuboidal or a bulbous columnar cell to a squamous. So it squashes the transitional epithelial tissue. So let me repeat that. Transitional epithelial tissue responds to stretch by changing its shape from a bulbous shape to a squashed shape. And that's why the urinary bladder, which is what transitional tissue mostly sits in, transitional allows the urinary bladder keep it from exploding because the cells slide past each other with pressure. So I just want to get that across. That's a little bit of fun. So now you know why you can actually accommodate liquid as it goes into your bladder. It squishes as pressure builds. Then we have glandular epithelial. Let's identify what a gland is. One or more cells that secretes a product. Usually it's a little indentation or invagination of an epithelial sheet. Okay, glandular epithelial tissue is, like I'm going to repeat, glandular epithelial tissue is one that secretes a product. It makes stuff. It's an active product that makes materials from the blood and releases it back to the blood. And we have 2 types of glands, everyone. Endocrine glands, exocrine glands. Endocrine glands are known as ductless glands. That means what's a duct? I'll show you a duct. And if I'm going too fast, slow me down in the chat room. Okay, here's a duct. A duct is like a little hallway, a canal. Now, make believe my fist is the gland. If there's a little duct coming out through which its products go, we call that an exocrine gland. And you can remember that because we're exit, right? The exit is a little tunnel, and exocrine glands have a little tunnel or a duct that secrete their products into a duct. Endocrine glands have no duct. That's its definition. Don't ask me why. Endo, no duct. And it makes hormones and secretes stuff right into the blood or lymph. The thyroid, the pituitary, the adrenal gland, all in another chapter at another time we're going to get into. That's ANP2. We actually start ANP2, and hopefully you guys want to sign up for ANP2. ANP2 starts with the endocrine gland. We have a good number of people signed up, 8. So it's going to be a smaller class, which is always nicer. But endocrine is talking about hormones. It's like an alphabet soup of different type of hormones. We talked a little about, right, insulin and glucagon and growth hormone in the last classes, but those are examples of hormones. There's a bunch of them. The endocrine system deals with that. So we're not going to talk any more about the endocrine system. We're saving that for ANP2, the alphabet soup of different types of hormones, which are chemical messengers in the body. That's the endocrine system. The exocrine is different. The exocrine deals with your yucky stuff. Saliva. You ever look in your mouth and press on a salivary gland and have liquid come out? I did, and I caused a tiny abscess. I'll tell you, you got to watch what you do with yourself. Anyway, that was years ago when I first started teaching ANP. You get obsessed with the subject. You know what I mean? So don't look in the mirror and press on your salivary glands to see them spray. They're delicate. Mucus. I'm kind of pretending to cough up some mucus. That's an exocrine gland too. So why don't we classify the exocrine glands into multicellular versus unicellular, based on their anatomy. A unicellular gland is a goblet cell, which we know is mucus, right? If you just have a single cell, boom, it's its own gland. It's a goblet cell. It's a mucus that makes mucus. If it's exocrine, multicellular, and simple, that means it has a single duct. That's your sweat glands, right? If it's compound, multicellular, exocrine gland, that means it has 2 or more ducts. That's your salivary glands, okay? So based on the anatomy, we break down the glands into whether it has 1 cell or more than 1 cell, so unicellular versus multicellular, and then whether it has a single duct or 2 or more ducts. And then you got to look at the physiology. How does stuff get made, in other words, by the glands? If it's made by exocytosis, which we know is just giving out materials and the cells are not altered, just a normal process of giving off stuff, then we say it's a mucocrine gland. Mammary glands that make milk, salivary glands that make saliva, sweat glands that make sweat, pancreas that makes pancreatic juice. These are all mucocrine glands. If on the test I ask you, what's the most common gland, exocrine gland, you got to say mucocrine, because that's, your average cell, your average gland. Holocrine are weird. That's your oil glands. I don't know. You can think of it as like a hologram of an oil well. I don't know. I'm trying to get you to get images to remember things, but holocrine glands rupture and die as they produce oil. So that's your sebaceous oil glands. And then your apocrine glands are kind of cool. Your apocrine glands are your nasty glands. We're going to talk about this when we do the skin. When we do the skin, we do hair, nails, sweat, all the gross stuff. We're going to do that on Thursday. But with apocrine glands, that's like in your armpit and in your private areas, your axillary areas or your genital areas, okay? Where the ends of the cell pinch off, you lose a little cytoplasm, and you make that nasty sweat that smells, all right? Lipid products of the mammary. We say it's debatable why we have that. Some say it's due to sexual attraction. This is a racy lecture. I don't want to talk about it yet. I'm not ready. I may blush. So we better move on. We'll talk about that during hair and nails. But that's your apocrine gland. All right, we're done with the epithelial. I want to move on to the connective. The connective is just that. If you don't know the answer in histology, just say connective, because that's pretty much all of the different types of tissues if you can't think of an answer. And the reason is there's so many different types. All of them do the same thing, though. They all bind and support other tissues one way or another. Bone, holds you up and binds you together. The knee bone's connected to the hip bone, whatever. And blood connects you and gives you your oxygen and food. All of them do a variety of functions: insulation, supporting, transporting. All of them have particular cells that are particular to them. Bone cells have bone cells, cartilage cells have cartilage cells, blood cells have blood cells, but they are all scattered in what we call an extracellular matrix. That is a matrix of non-living materials, of fibers and ground substance. And I want to show you what this is. And by the way, the connective tissue is the most varied of all the tissues, and it is the most abundant tissue in your body. Obviously, fat, bone, and lining is most of what we're made of, right? I mean, when you strip that away, the only thing left is some nerves and some muscles. I mean, there's not much. So we're mostly connective tissue, connected all together. How are we connected, everyone? Extracellular matrix is made up of ground substance, as you can see on the projection here. The ground substance is the non-living material made of cell adhesion proteins, which is glue, glycosaminoglycans. That's one of the longest words I know. Makes me feel very important. You can call them gags. If you do any cooking, you know that you thicken a gravy with starch, right? You put or cornstarch, or you put some flour and water and you thicken it. Not that I'm the greatest cook. I cook to my own tastes, everyone. I should really have a big party at the end of this whole thing and cook you some sort of goulash. But my point is, glycosaminoglycans thicken the extracellular matrix of the connective tissue, okay? So depending on the tissue, you have thicker or thinner tissue. You have thick tissue when it comes to bone, right? Very hard. You have thin tissue when it comes to blood. You better not put a lot of gags in there. So here's a picture of a gag. It looks like a feather. That's what makes it thick, all right? It's a thickening agent. So why am I spending all this time? My point is to say that all of the connective tissues have a ground substance with stuff in it to make them thicker or thinner. All of them have particular cells in there. And all of them have fibers. And you better know these three fibers: collagen, elastin, and reticular. Because I'm telling you, it's not just me. My research was on collagen, but fibers really are what dictate the anatomy of our body. Let's talk about collagen. I wrote a whole thesis on collagen, okay? I have done a ton on collagen. They're white fibers, they're very strong, and they are used for tensile strength. They are used to keep your materials strong. So when you have strong blood vessels, strong kidney, strong heart, all that is because collagen keeps everything together. And with age, collagen does this. Look, cross links, goes like so. Instead of being nice and parallel, it crosses and becomes brittle and breaks. And we believe that is the loss of collagen, the destruction of collagen, is definitely related to the aging process. Some things accelerate aging. I better not say this because I'm gonna put this on YouTube. I have a person I know, okay, and they're like 10 years younger than me, and they're more wrinkled, I'll tell you that. And it's because they use a tanning booth. Tan. I told her, tanning, gonna cause collagen cross linkages. And of course, wrinkling goes with that. The less collagen you have in your skin, the more wrinkled up you are. UV light, sunlight, smoking, all of that decreases collagen in your body, causes more collagen cross linkages, which make the collagen brittle and break. So, that's an important point. Now pull your face and watch it plop back. As you get older, it just stays. I'm happy. Let me see myself. I got to look at myself. Oh, thank God it's coming back. Okay, good. You pull it, it comes back. As you get older, it just stays. And that's elastin. Elastic fibers are yellow fibers. That might be on the test. Yellow fibers. Collagen fibers are white fibers. And the elastin fibers, we say it has a high Young's modulus. You don't have to know that till you get to grad school if you go on and get your doctorate or your nurse practitioner degree. But that means it has a good ability to return back to normal. That's known as Young's modulus. Don't write that down, for God's sake. You just have to know what's in the notes. They're yellow fibers. They're elastic like a rubber band. If you remember the word elastic fiber, remember elastic rubber band. It's in your lungs, so your lungs can return back to normal. It's in your face and your skin, in your organs, because you need things to stretch and return to normal. For example, there's a disease known as Marfan syndrome where the elastic fibers are not formed properly. And your aorta, which is the blood vessel that accommodates fluid as it leaves your heart, can rupture and, form what we call an aneurysm or a ballooning out. And the guy who died from that on Three's Company. Does anyone know Three's Company? That's a show in the 70s. I used to watch it as a kid, And the guy, John Ritter, he died of that. So your parents would probably know. You're too young. But you may watch some of the old shows. They were nice. The three lived together. Anyway, but he died of it because he had Marfan syndrome. That's an example. Reticular fibers are much less fun to talk about. They're basically fibers in areas where connective tissue joins together with other connective tissue. So while not an exciting tissue to talk about, you need them, okay? You got to have them. Now let's move on to just the general structure of connective tissues. Each connective tissue type has its own cell, like I said. Cartilage cell has cartilage. We call it chondrocytes. Bone cells have bone cells, osteocytes. I never heard anyone use the word hematocytoblast, but if you want to get technical, that's a blood cell. And there's three, so each type of connective tissue has its own cell type, right? Bone cell has bone cell, blood cell has blood cell, cartilage cell has cartilage cell, all right? But we can't just say cartilage cell. You got to say chondro. You got to say osteo. Osteo means bone. Chondro means cartilage. And if the cell is immature, it ends in the word blast. A suffix means It ends in a suffix known as blast. Suffix means end of a word. So an immature cell ends in the word blast, a mature cell ends in the word site, and a very developed cell that breaks stuff down is known as a clast. It ends in a clast. It's a destroyer. So an osteoclast is a bone cell that breaks down bone. An osteocyte is a bone cell that, maintains homeostasis of the bone. It's non-dividing. An osteoblast makes new material. We say that it makes the ground substance and the fibers. You know how I remember that? The word blast is like, you blast out new material. Like that's how they put insulation in. So, you just blast out, like in an attic, you blast out the insulation. You just blast new material. So a fibroblast adds new tissues. We're going to talk about fibroblasts in tissue repair when we meet again tomorrow. So anyway, let me give you a quick overview of the different types of connective tissue. All the connective tissue come from something known as mesenchyme. All right, mesenchyme is the embryonic connective tissue of the body. And it gives rise to either connective tissue proper, cartilage, bone, or blood. Connective tissue proper is broken up into either loose connective tissue or dense connective tissue. And if you open up, take a minute, maybe we should open up to the atlas in your manual. Lab exercise 4 has an atlas in your manual. And there's nice pictures of all the different types of connective tissue. If you look in your textbook, if you don't want to go to your manual, just look in your textbook on page 401 and 402. Figure 11.15 has these different types of connective tissues strewn about. Figure 11.14 on page 400 has a picture of the general structure of connective tissue. So it's all there. Maybe you should just stick with the textbook so you're not rummaging around the atlas. But I just want you to see the pictures as we go through, so I'm not lying and making all this up. But the loose connective tissue, as you can see, let's take the loose. Page 402. Your reticular, your areolar, your adipose, all of these are loose connective tissue. Areolar is like your cushioning tissue. Loose means strewn about, like your room's not organized, clothes all over, it's loose. Dense means very organized, like your ligaments and tendons are very organized, and your elastic tissue. So why don't we talk about the loose first, all right? Because that's easier. I want you just to be familiar. Again, on the test, you might have a matching column or a couple of questions about, the characteristics of each of these, all right? Again, because it's an online class, you don't have to memorize every single thing, but you should be familiar with your notes and where to find it. A couple of you had some trouble on the first test. And my advice to you is that it's a way of studying. It's different. I'm a memorizing machine, okay? I never had an online class. For God's sake, I learned on a typewriter. I did my thesis on a typewriter. We didn't have online. But, if you have a take-home test, it's different. And I did a lot worse on take-home tests. I'm going to tell you, because my strength was memorizing. Take-home tests mean you got to look for the answer in your notes. Now, most people did all right, but those people who did not, my advice to you is you got to change your strategy. You got to be familiar with your notes. Put a little highlighter. And like, for example, now, as we go through this, highlight the important points that stick out. So areolar connective tissue. You should highlight universal packaging material. Wraps and cushions the different organs, all right? That's its main function, right? And, the rest, it's all, you might have that in here. Basically, you have a lot of gags. It's very viscous. Viscous means thick. So you can't let bad cells go through. So areolar connective tissue, what am I getting at? Is the universal packaging material. It packages your tissues, your organs, your blood vessels in your body. So I think of them as packaging peanuts. And during lab, during the year, I have a little packaging peanut box, and I bring it out for people to remember. So, you might want to close your eyes and envision that. I don't have it with me here, but packaging peanuts. Otherwise, you know, if you're making a left turn, all your organs would go to the right and get ripped apart. The areolar connective tissue cushions and allows it to be safe. Adipose tissue is fat. You know, fat gets a bad rap, but 90% of the tissue mass of adipose tissue is fat, found in large vacuoles. I have a picture of it on page 402. I guess letter F, adipose tissues. You can see large amounts of fat storage in the adipose tissue. The average person has about 18% adipose. Women are 20 to 25%, men, you know, 12 to 18%. But, you know, on average, we're almost about a fifth fat. And you need it for nutrient storage, protection. Babies need it, especially for generation of heat. Baby fat is brown fat because it has a lot of mitochondria, and mitochondria look brown under the microscope. And as a result, baby fat generates heat for babies. And fat is very well vascularized. You should remember this word. Vascularized means blood vessels, a lot of blood vessels. And that links to metabolism. In other words, metabolism is your chemical reactions in your body. If a tissue is well vascularized, that means it has a lot of blood vessels going to it. Usually that means there's a lot of stuff going on. And stuff going on means metabolism, right? A lot of stuff happening. Reticular connective tissue. Everyone feel your neck, feel little lymph nodes. There's little bumps in your neck. And, you know, pea size, half a pea size. I mean, they shouldn't be a golf ball because then you could have lymphoma, cancer of the lymph. I don't want to make you paranoid, though. So, you know, feel your neck. And, you know, it's made up of an internal framework of reticular fibers. That's why it's called reticular connective tissue. It looks like a spider web. We've got a picture of it, figure 11.15G, page 402. It's reticular. It's not my favorite picture because it doesn't show all the lines, but it does kind of give you an idea of the fact that there's a lot of fibers around. And the fibers trap, you know, in the lymph nodes, in the spleen, in bone marrow, it traps the invading cells, bacteria, cancer cells, any things that need to be trapped and brought into the lymphatic system. As I told you, the lymphatic system is kind of the sewer system of the body. It picks up all the extra stuff that the blood vessels don't keep in their body, in their vessels. So some of those things are cancer cells, which go to the lymph nodes. Some of these things are, you know, maybe wandering bacteria that go to the lymph nodes. So anyway, then we have dense regular, and dense regular connective tissue is our first dense tissue. Dense means a lot of stuff in there. See this picture? We got a lot of fibers going in one direction. And these are parallel bundles of connective fibers. Let's look at page 401. Figure 11.15D is basically an example of dense regular. Ligaments and tendons, okay? Ligaments connect B to B, which means bone to bone. Tendons connect muscle to bone. Most of us have heard of those words, all right? But now I want you to remember, muscle to a bone is a tendon. Ligament, bone to bone. So these are straps that hold your muscles and your bones together. Aponeuroses is a word, my God, you don't see very often, but I got to put it in. Connects a muscle to a muscle. It's a tendon that connects a muscle to a muscle. Well, what's the point? Why have a dense regular connective tissue? Because you need a strap that's really strong, right? And all of your fibers go in one direction to keep it strong, holding the muscle of the bone or the bone of the bone. That's why dense regular is structured the way it is. Let's look back. Adipose, why is it structured the way it is? A lot of vessels to get the fat in and out because you need fat as you live, must have energy. Why is reticular looking like a spider web of a bunch of reticular fibers? Because it traps stuff. Just like a spider traps things, so too does the lymph node. So I want you to appreciate the beauty of the different types of tissues, not just memorize, all right, reticular, lymph node. You can do that, but And that's what I'm going to test you on. So you got to be familiar with these characteristics. But I want you to have a little fun with this and say, hey, it's interesting that all of my stuff in my body and in people's body is made the way it is for a reason. Elastic connective tissue, elastic ligaments, ligamenta nucha, we call it, means the ligaments between the vertebrae. Again, needed to be elastic, otherwise you would not be flexible. You need a backbone that's strong and flexible, unlike most politicians. See my little humor there? I always pick on the politicians, both parties. Dense irregular connective tissue, irregular arrangement of collagen fibers, okay? Basically large fiber bundles. Dense irregular is like the dermis of your skin. Take your skin, push it this way, push it this way, push it this way. Many planes of tension, many pulling. You want it strong, so therefore it's dense, right? The dermis of your skin. In other words, the layer underneath your skin. You want it strong, that's why it's dense. And it's irregular because it's not all in one direction. You don't want to just pull one way. You want it to be able to go in many directions. Last but not least are the types of cartilage. Cartilage, there's an old saying, a fool and his cartilage is soon parted. Cartilage is somewhere between bone and tendon in its strength and consistency. If anyone ever likes Kentucky Fried Chicken, which I love, but I cannot have but like once a year because of my blood pressure. I'm a borderline case with the blood pressure. But anyway, if you eat the end of the bone and you see the white stuff come off, and it's kind of hard. I do not eat the cartilage, by the way. That's disgusting. My parents ate it. Europeans, absolutely not. But anyway, I do not like cartilage. I will say that right away. But that's the consistency of the cartilage, the white stuff at the end of the bones and of Kentucky Fried Chicken. But that's as close as I come to it. Cartilage resists tension and compression depending on the type of cartilage it is. And cartilage is mostly water, 80% of water. It has no nerve fibers, and it's avascular. Avascular means no blood vessels. Write that word next to the word avascular, no blood vessels. And it is nourished by diffusion, right? Just simple movement. Diffusion, you can't move things very far. Very close distances, you can move things. So diffusion nourishes the cartilage. Cartilage mostly water anyway, so things get in and out very quickly. But it does not heal well, everyone, because it's avascular. And I'll address that in the next class. I want you to know the three types of cartilage. Number 1, hyaline. Number 2, elastic. Number 3, fibro. Hyaline cartilage is your most common. It's, if you push on your nose, go like this with your throat. The rings of cartilage around your trachea, of your windpipe, your nose, push on it. Oh, that's definitely hyaline cartilage. That's what you see. That's gristle. When you eat it on the end of a bone, that's what it looks like, gristle. You're not supposed to call it gristle, everyone. Do not say the word gristle to the doctor, or you will look ridiculous. It's called hyaline cartilage, but I just put that in so you remember Kentucky Fried Chicken. That's what it looks like. But it's always compressive, and it has a lot of strength. That's why it's the ends of the long bones, cushioning the long bones, in your nose, and your trachea. The embryonic skeleton is almost completely hyaline cartilage. Now pull your ear, everyone. Pull your ear. The pinna, or outside of your ear, has a lot of tensile strength. That means pulling strength. So you'll find that it's made of mostly elastin, those types of fibers, that cartilage. And your epiglottis, that's your flap on top of your windpipe, that's made of elastic cartilage. It kind of covers your windpipe and in a nice, good fit. That's why it's elastic cartilage. And that makes sense, common sense, because you don't want water getting into your windpipe, right? Or any liquid. Then we have fibrocartilage. That's in your back, the discs in your back, and they resist compressive and tensile forces, right? So if you stand up, it's a good time to stand up. We're almost at the end of the lecture, and you move back and forth. You know that your back has to resist what? Compression on one side and tension on the other. Every time you walk, it compresses you. In fact, everybody, you shrink a ½ inch to a quarter of an inch between morning and night due to the pressure on your fibrocartilage water leaves, right? We said your discs are made of 80% water. Water leaves the body, excuse me, water leaves the discs as you put pressure on it. And then I want to end with bone and blood. Bone and blood can't be any more different. And that's why I started the lecture as I will end the lecture. Cartilage, connective tissue is very varied. So many different types, from reticular to cartilage to now blood and bone. And the bone is made up of organic salts that make a very strong matrix. We will talk about osteoporosis or thinning of the bone in another lecture, but the matrix gets weaker as we get older. And it's very well vascularized. We'll talk about in the bone lecture just how easy it is to heal bone because it has many vessels. Blood is completely different. The ground substance is fluid. The fibers are soluble proteins that only come out with clotting. So it's a totally different structure. And we're going to spend an entire unit on nerves and muscles, everybody. That's your exam 3. It's your orthopedic unit, where nerves, bones, and muscles are addressed. And that's the end of our A&P 1 course. I see some people crying. I know, it'll be sad. But let's talk about the nervous system. What do you see before you? You see a wire, and the wire is known as the axon of the nerve. You don't have to know that right now, but I want you to know that the nerves transmit messages and have electricity to move those messages from one part of the body to another very fast. And the word neuron is nerve cell. So your average nerve cell is known as a neuron. It looks generally like this, a wire that transmits messages. And your neuroglia are support type cells. The neuroglia insulate and protect the actual nerve. When we say Einstein had more neuroglia than the average, that's why he was able to figure things out. Don't know. Don't know. Many theories. Last but not least, muscle. We're going to talk about skeletal muscle in great detail. Again, bones, muscles, and nerves are your last 3 lectures after this week. Believe it or not, we only have 3 lectures left after this week. So we're in pretty good shape to be done. You've gotten through, now at this moment, more than half. So you're at your midterm time. Let's talk muscles. You've got just the idea that muscles are long cells. They're very long. They can be 3 feet long. No, they can be 3 feet long. No, that's a lie. What am I saying? They can be, what's the longer one? They can wrap up to 2 feet, I guess. Between 2 and 3 feet. I was exaggerating a little. So they're long cells. They are well vascularized, again, meaning that they have a lot of blood vessels going to it. They have a lot of protein in it. You want to build up muscle mass, you got to have a little bit more protein. You know, you go from 10% calories of protein to 12 to 14%. And myofilaments are the filaments that contract like an accordion in muscle that are made of protein. And actin and myosin are the most common proteins in muscle. We'll talk more about that at another time. I want to direct you to our chart, looking at the 3 types of muscle: skeletal, cardiac, and smooth. Let's first talk about skeletal. Skeletal are obviously attached to bones. They are long cylinders, and if we look at the muscle cells on page 404, figure 11.16, there's a comparison in your textbook of the different types of muscle cells, how they look. Skeletal cells are long cylindrical cells. Heart cells, obviously known as cardiac cells, are long and branch types of cells. That's letter A. And then smooth are spindle-like. They are always found on the organs. Now, striations mean lines, little lines. And if you look on page 404, you'll see A and B, cardiac and skeletal muscles, have little lines, right? These are desmosomes. They make the tissue stronger. So skeletal and cardiac tissue is stronger than the smooth. You know, if you've got muscle on your stomach, right, that's smooth muscle. That ain't going to be as strong as on your bones or in your heart. Is it voluntary? Skeletal is voluntary. Move your arm? Yep, I think so. Skeletal muscle moves your arm. You think about it, you move it. How about your heart? Not voluntary. You don't say, hey, I think I'm not going to beat my heart today. That's ridiculous. So cardiac cells are not voluntary. Same thing with the smooth. You're not going to say, I don't think I'll have, nope, not going to digest the ho-ho. Tell the stomach not to digest it. You can't do that. So cardiac and smooth are not voluntary, so I wrote a little negative. Skeletal is voluntary. And last but not least, does it have a nucleus? Multinucleated. We say skeletal muscle is multinucleated because skeletal muscle is very long and needs a lot of control centers to control the different parts of the cell. Cardiac and smooth are unicellular. Now we are exactly 1 minute over time. So that's it for the lecture. Let me pause the lecture or pause the recording. Actually, we can leave it. Let's leave the recording and just take questions. Ladies and gentlemen, what I'd like to do now is open up to questions that you may have. Unmute you. Whoops. Let me unmute you. Hold on. Sorry about that. I can't figure that out. Worked last time. New participants upon entry. All right, I'll allow you to unmute yourselves. We'll do that. And let me pause the recording. I think I'm done with this. Whoops. Okay. I want to open up the chat